Look at this silent red sphere. From orbit, Mars appears entirely still, a frozen desert drifting through the vacuum. But as we drop closer to the surface, the uniform dust gives way to a sprawling blemish carved deep into the crust. This is Olympus Mons. This satellite view highlights the central caldera, surrounded by a ridged shield structure that radiates outward for hundreds of miles. Up here, the sheer drop of space flattens everything. To actually comprehend the mass of this rock, we have to bring it down to human terms. On Earth, this is our ultimate benchmark. Mount Everest pushes nearly 9 kilometers into the sky, representing the maximum height our planet's gravity and crust can typically sustain. When we place Everest at the foot of Olympus Mons, the scale is jarring. Earth's highest peak is nearly 3 times shorter. But the disparity isn't just height. The mountain's base covers an area roughly the size of France. This creates a striking physical paradox. Mars is roughly half the overall size of Earth. If we placed a structure this massive on Earth, our higher gravity would cause the crust to buckle and sink into the mantle. The fact that it stands at all is only possible because Mars operates on an entirely different scale of gravity. To understand its scale, we must stand at the absolute foot of the volcano. You wouldn't find a gradual ramp. You'd be facing an outward-facing sheer cliff that rises 8 kilometers straight up before you even set foot on the mountain's slope. Once you finally clear that vertical wall, the terrain levels out into a gentle, seemingly endless incline that continues toward the peak. On Earth, mountain ranges are forged in long, messy lines as tectonic plates crumple the crust. But this singular, abrupt perimeter shelf suggests the mountain didn't rise from a collision. It grew in total isolation as a single, massive pile of rock. The surface is paved with physical evidence of ancient, frozen lava flows, built up over eons. On Earth, moving tectonic plates shift over stationary magma plumes, creating chains of separate islands like Hawaii. But the Martian crust stays locked in place. The magma pumps into the exact same spot for billions of years. This stationary geological engine allowed an unending buildup of rock to stack higher without interruption. Mars's significantly lower surface gravity provided the final ingredient, allowing the mountain to support this unimaginable weight without collapsing under its own mass. Olympus Mons is the direct physical manifestation of a planet that evolved by stationary rules. Now, follow that gentle slope all the way up to the edge of the central caldera. At the summit, you are met with a strange physical reality. The volcano is so wide that its flanks stretch entirely past the visible horizon. Because of the sharp curvature of the small planet and the immense width of the shield, an observer standing at the peak wouldn't visually perceive they were on a mountain. The terrain would appear completely flat. It is a structure so large that it successfully hides its own planet-warping scale. Look out over the panoramic expanse as a glowing Martian sunrise begins to crest the distant horizon. This silent, frozen landscape is a stark contrast to the violent, fiery eruptions that originally built this peak. Olympus Mons now serves as a permanent time capsule, marking the exact era when Mars' crust locked into place and its interior finally cooled. It is a towering, beautiful tombstone, the final, silent monument to the violent past of a planet that has permanently gone to sleep.